Hello and welcome back to Engineers Olympiad. We're doing the numerical questions for the topic weight volume relationships in geotechnical engineering. We have done a lot of numericals before this video lecture, and those video lectures are already uploaded on this channel. You can watch those videos before watching this video. So let's get started. Question is, a sample of clay taken from a stratum was found to be partially saturated, and when tested on in laboratory gave the following results. Specific gravity of soil particles is 2.60. Wet weight of the sample is 250 grams. Dry weight of the sample is 210 grams. Volume of sample is 150 cc. We have to compute the degree of saturation. Alright, so let's solve this question. What data has been given? Specific gravity, wet weight of the sample, dry weight of the sample, volume of the sample. We have to compute the degree of the saturation. Since both wet weight or bulk weight or moist weight and dry weight of the sample has been given, we can very easily find the water content. Water content is equal to wet weight or bulk weight or moist weight, that's 250 grams, minus dry weight of the sample, that is 210 grams, divided by 210, that is 19.04% is the water content of the sample. Alright, but our goal is to find the degree of saturation. See how we'll arrive at this. Next thing, we'll find the bulk unit weight. Bulk unit weight is weight per unit volume. But which weight? Weight in the bulk state or the moist state or the wet state. That is how much? 250 grams. So 250 grams. Volume of sample is 150 cc. Volume of the soil sample is 150 cc. So upon calculations, this will become how much? This is 1.66 grams per cc. Alright, so this is 1.66 grams per cc. Next, we'll find the dry unit weight. Dry unit weight is also weight per unit volume, but which weight? Weight in the dry state, that is 210 grams. 210 divided by volume of the soil sample is same, 150 cc. 150 cc. So upon calculations, this becomes 1.4 grams per cc. Alright, next we'll use the alternate equation of this dry unit weight to find out the void ratio. We're doing everything to calculate degree of saturation, and for degree of saturation I'll be using this equation. ES is equal to WG. I know this, I must be knowing E to find the degree of saturation. That's why we're doing this. The alternate equation for finding the dry unit weight is G, unit weight of water, divided by 1 plus E. This is how much? Already calculated, 1.4. G, as per the question data, is 2.6. Unit weight of water is 1 gram per cc divided by 1 plus E. 1 plus E becomes 1.85. That means E becomes 0.85. So now we have the void ratio. We can very easily calculate degree of saturation, and that is what the question had demanded or asked us to find. Degree of saturation using the generalized equation is equal to WG by E. We know this, and this. We can easily calculate degree of saturation. Water content we have calculated in the very beginning. It is equal to 19.04%. So it will be this. G, as per the question, is 2.60. E, we have just calculated 0.85. So S is equal to 58.24%. Degree of saturation is 58.24%. Alright, so this is about this question. Alright, let's move to the next one. Next question is, a natural soil deposit has a bulk density of 1.86 grams per centimeter cube and water content of 5%. Alright, calculate the amount of water required to be added to 1 cubic meter of soil to raise the water content to 15%. Assume the void ratio to remain constant. What will then be the degree of saturation? Assume G equal to 2.68. Alright, so this is the question. We'll be solving this. Now let's see what data has been given. A natural soil deposit has a bulk density of how much? It has a bulk density of, I think I changed the color of the pen. Over here. Yeah, it's white. Bulk density is how much? Bulk density is, I have to erase it. I don't. Okay. Bulk density is, as per the question, it is 1.86. Right. It is 1.86 grams per cc. And the water content is how much? It is 5%. Calculate the amount of water required to be added to 1 cubic meter of soil to raise the water content to 15%. Then we have to assume the void ratio to remain constant, and then we have to calculate the degree of saturation as well. See how I shall proceed with the question. We have been given the bulk density and the water content. I'll calculate the dry density. Dry density is bulk density divided by 1 plus water content. So dry density is 1.86 divided by 1 plus 0.05. Upon calculations, it is equal to 1.77 grams per cc. Alright, this is the dry density. Now, water content is mass of water divided by mass of solids. Alright, that means mass of water is water content multiplied by mass of solids. That means mass of water becomes water content is how much? 5% multiplied by mass of solids. That is, I can write dry density multiplied by volume. That is equal to mass of solids. Alright, because this is this, so this becomes this. Right, I use the same over here. Now mass of water is 0.05 into dry density that I calculated was how much? 1.77 grams per cc. So I write 1.77 grams per cc multiplied by volume. See, we have been given in the question, all I am doing is that I am calculating the amount of water that is required to this 1 cubic meter of this soil to raise its water content to 15%, from 5% to 15%. So volume is 1 cubic meter. I have to see how much water do I need to add to 1 cubic meter of this soil so that its water content will raise from 5% to 15%. So volume is 1 cubic meter. So I'll write it here. Volume of soil is 1 cubic meter, and 1 cubic meter is 10 raised power 6 centimeter cube. Alright, so since this is in gram per cc, that's why I have to change the units of this. 1 cubic meter is 10 raised power 6 centimeter cube. So mass of water by this becomes 8.85 into 10 raised power 4 grams. Alright, this is the mass of water, right? Now I'll be calculating the mass density of water. Mass density of water is how much? Mass density of water is mass of water divided by volume of water. Volume of water is mass of water. All I am doing is to calculate the volume. Mass of water divided by density of water. Now mass of water I have calculated 8.85 into 10 raised power 4 grams divided by, we know the density of water, it's 1 gram per cc. That means volume of water is 8.85 into 10 raised power 4 centimeter cube. This was gram per cc. This was how much? This was also gram per cc. This was gram, sorry. This was grams. This was grams per cc. So this was mass of water. This was in grams. This was gram per cc. So unit is cc or the centimeter cube. So this is our volume. That means, and now let me convert it into liters. All right. We know that 1 cc is equal to 1 ml and 1 cc is equal to 10 raised power minus 3 liters. That means volume of water which is required to be added to 1 cubic meter of this soil so as to raise its water content from 5% to 15% is 88.5 liters. Alright? No, it's not 88.5 liters. This is the volume of water I calculated at the current state of 5% water content. So this is the current volume of water in the soil at this 5% water content. Now what shall I do? I'll use the same computations, but I'll take my water content as 15% and then I'll calculate the volume of water there, and then I'll be subtracting the two. That will be my volume of water to be added to the soil so as to raise its water content from 5% to 15%. Alright students, so this was the water content at the current level of water content, that is 5%. All right, see how we shall be doing this now. Now when water content is how much? Now water content is 15%, that means 0.15. I'll be using the same computations to calculate the volume of water in that state. All right, so mass of water, as you can say, mass of water is water content multiplied by mass of solids. Mass of water is how much? Mass of water is water content 15%. Soil solids, I'll be using the same dry density. All right, dry density multiplied by the volume that we used earlier. So mass of water is 0.15, dry density we have calculated 1.77 gram per cc, volume is 10 raised power 6 centimeter cube. So mass of water by computations becomes 26.55 into 10 raised power 4 grams. Now I have to calculate the volume of water, which is mass of water divided by density of water. So mass of water in this case at 15% water content, it is 26.55 into 10 raised power 4 grams. Then we have density of water 1 gram per cc. So volume of water in this case becomes 265.5 liters is the volume of water at 15% water content. And this was volume of water at 5% water content. So how much water do you need to add to the soil so as to raise its water content from 5% to 15% is the subtraction of the two. All right. So hence I write it over here. Hence the amount of water required, the amount of water required to be added to raise the water content from 5% to 15% for 1 cubic meter of this soil is 265.5 liters minus 88.5 liters, which is equal to 177 liters. Alright, so with this we have calculated the first part of the question that asked us how much amount of water is required to be added to 1 cubic meter of the soil so as to raise this water content from 5% to 15%, that is 177 liters. Let's move to the next part. Next part says, assume the void ratio to remain constant, what will be the degree of saturation? Now I have to calculate the degree of the saturation assuming void ratio has remained constant. Alright, now we know the dry density is, I'm using the alternate equation for dry density so that I can compute my E. So dry density, as we have already calculated, it is how much? It is 1.77. G is 2.68 as given in the question data. Yeah, assume G 2.68. Density of water 1 gram per cc divided by 1 plus E. Upon calculations, E is equal to 0.514. Now we have E, we have water content, we have G. We can very easily calculate the degree of saturation. Degree of saturation, as we know, is equal to Wg divided by E. Water content is how much? It is not 5%, it is 15%. Mind it, water content has been raised. So now the water content is 15%. G is 2.68. Void ratio we have just calculated as 0.514. 0.514. So this question has the answer for degree of saturation as 78.2%. Alright, so with this we have calculated, or rather completed, this question in all respects. Alright, so let's move to the next one. Alright, next question says, show that the degree of saturation S is given by this expression. We have to derive this expression for the degree of saturation. Alright, so let's do this. Proceeding step by step, we have bulk unit weight is, as per the generalized equation, G plus SE. Alright, divided by 1 plus E. This is the generalized equation for the bulk unit weight. Let me name this equation 1. Alright, also as per the generalized equation, E is Wg by S. Let me name it equation 2, or equation A rather. Alright, equation A. We'll substitute the value of equation A in equation 1 and then we'll be having our expression. See how? Substituting the value of equation A in equation 1, we have, this is equation A first, This is equation A. Will be substituted value from the equation A in equation first. So see, bulk unit weight is G plus S. Instead of E, I have to write this Wg by S, unit weight of water, divided by 1 plus E. Rather than E, I have to use Wg by S. So here it becomes G plus this and this will go Wg, unit weight of water, divided by 1 plus Wg by S. So I can write it like this. This will go here. 1 plus Wg by S is equal to G plus W G rho W, or this will go here. Alright? Alright. So let's do some taking something common from here. We'll take G. It will become 1 plus W. This will be like so. Alright. Now let me write it like this. Wg by S is G 1 plus water content. This by this will go here. This one from this side. This will go here to this side. Alright. Now this and this will go. So W by S rather is 1 plus water content, this minus 1 by G. Alright. So let's do some. I have to take the value of S. So S becomes how much? S is this. If this will go here, this will be 1 plus W, this minus 1 by G. And that's what we had been asked to prove. See? Show that the degree of saturation S is given by S is equal to water content, this 1 plus W minus 1 by G. That's exactly what we have proved over here. Let me rewrite the expression. So this means S is water content divided by this 1 plus water content minus 1 by G. Alright, where this stands for water content, this is the unit weight of water, and this is the specific gravity of soil particles. Right? This is the specific gravity of soil particles, and we have proved this expression that S is equal to this. Alright, so with this we conclude this video lecture. I hope it was useful and I hope you enjoyed watching this. Thank you once again. We'll be back with more video lectures on the same topic because we are trying to cover as many numericals as possible. Maybe we'll be having more of it, and some 4 to 5 video lectures we're expecting more on the same topic. So do stay tuned to Engineers Olympiad. Thank you.